section 2.7 talks about transformations of graphs. And so we're going to first talk about these things called vertical and horizontal shifts. And it says, let f be a function, let c be a positive number. So number c is going to be positive. And it says, if we're going to graph y equals f of x plus c, we're going to be moving our graph upward, c units. If we are going to then graph y equals f of x minus c, we're going to be moving our graph downward. And then if we're going to be graphing y equals f of x minus c or f of x plus c, we'll be moving our graph either to the right or to the left. Okay. So what I'm going to do is, in all these problems, I'm going to use this idea here of this table to figure out, am I going to move my graph up, down, right, or left? Okay. So here it says, given the graph y equals f of x. So here's my graph, right? And they have it also in a table function. So just so you know, how did they get this? Look at this point right here. It's the point negative 1, 2, negative 1, 2. Look at this point here. It's the point 0, 1, 0, 1. And the last point is 2, negative 1, 2, negative 1 right there. Okay? So now we're going to graph y equals f of x plus 2. So I'm going to come back over here and I'm going to say, hey, you know what? That looks just like the first one. So what am I going to do? I'm going to move my graph upward 2 units. So that means that my x values, guys, my x values are going to stay the same. That's going to stay negative 1. That's going to stay 0. That's going to stay 2. Okay. Now, what I'm going to do, look right here. It says f of x plus 2. Here are my f of x values. What am I going to do with those numbers? I'm going to add 2 to each of them. So negative 2 plus 2 gives me 0. 1 plus 2 gives me 3. Negative 1 plus 2 gives me positive 1. Okay. And then what I'm going to do is I'm going to go ahead and plot those points right here. So negative 1 and 0 would be here. 0 and 3 would be here. And 2, 1 would be here. And if you noticed, and I'm going to try to zoom out a little bit. Let's see if I can do that here. I'm going to zoom out just a tiny bit. Whoa, threw me off. But it's okay. We'll find what we're looking for. Here we go. And so if you notice, all we basically did here, guys, is we took this graph here and we moved it up 2 spaces, okay? So let's try this next one, okay? So same function right there, right? We're now going to graph y equals f of x minus 1. So I'm just going to scroll back up. Okay, so if you look right here, I know I'm zoomed out a little bit, but if you look right here, f of x minus c, that means I'm going to go downward, okay? So in this case, I'm going to go downward by 1 spot, okay? So that means my x values are going to stay exactly the same. That'll stay negative 1, that'll stay 0, that'll stay 2. Look what I'm doing to my y values. I am subtracting 1 from each of them. Okay, so minus 2 minus 1, minus 3. Okay, 1 minus 1 is 0. Negative 1 minus 1 is a negative 2. Okay, and now all I'm going to do is plot these points. So negative 1 and negative 3 is down here. 0 and 0 is right there. And 2 and negative 2 is right here. And again, all we did is we took this original function and we brought it all down 1 space. Okay? That's all we're really doing there. Right? Okie dokie. So I'm using the same function I had before, right? And what are we doing now? Let's take a look. We're going to graph, y equals f of x minus 2. Okay? Y equals f of x minus 2. So I'm going to come back up here. And let me erase some of this mess. Okay. I'm looking at this piece right here. And if you notice this part, y equals f of x minus c, it says I'm going to the right. And if I have y equals f of x plus c, it says I'm going to the left. Okay, so if I'm going to the right, I know it has a minus, but it says I'm going to the right. Okay, so to the right would be that direction. So let me come back over here. Okay, if I'm going to the right, in this case, I'm going to go to the right 2 spaces, right? So I'm going to take each of these values and I'm going to move them over to the right 2 spaces, 2 spaces. So what that means I'm doing is I'm taking my x values and I'm actually adding 2 to each of them, okay? So -1 plus 2 would be 1. 0 plus 2 would be 2, and 2 plus 2 would be 4. My y values, guys, are actually going to stay exactly the same. -2, 1, -1. So now, let's go ahead and plot those points. So 1 and -2 would be right here. 2 and 1 would be right here. And 4 and -1 would be right there. And again, if you notice, all we have really done, guys, is we took this function here and we moved it to the right 2 spaces. And you might say, I know it has a -2. Why are you adding 2? The reason I'm adding 2 is because I'm going what direction? To the right. So if this has a minus on the inside, you're going to do the opposite. You can actually go to the right, okay? All right. We got another one, just similar to the one we did before, okay? But now, look what we have here. We have y equals f of x plus 1. So that means I'm going to go to the left 1 space. Okay. So I'm going to take each of these points. I'm going to move them 1 space over to the left. Okay. So if I'm going to go 1 to the left, that means I'm actually going to subtract 1 from each of my x values. So -1 is -2. 0 minus 1 is -1. 2 minus 1 is 1. My y values will stay exactly the same. Okay. So let's go ahead and plot those points. -2 and -2 would be here. -1 and 1 would be right there. And +1 and -1 would be right here. And again, all we've done is moved our graph 1 space over to the left. Okay. All right. So now we have something called vertical stretching and shrinking. Okay. So guys, one thing I want to mention, when it's vertical, this is going to change my y values, okay? So it says, if the point xy lies on the graph of y equals f of x, then the point x, and notice what it has right here, c times y. You know what, let me zoom in because I know that's a little hard to see. I'm having a hard time seeing it myself, but I'm also going to be 47, so. Alrighty. Where is we? We're almost here. We go. Okay. All right. So it says the point xcy lies on the graph of y equals cf of x. So it says if c is bigger than 1, then the graph of y equals c times f of x is a vertical stretching of the graph. And when c is between 0 and 1, then y equals c f of x is a vertical shrinking of the graph. Okay, so let's see what they mean by that. So it says, given the table here we have y equals f of x. We want to make a table for y equals 2f of x. So I want you to notice something, guys. The 2 is on the outside. When the 2 is on the outside, what we're going to change are the y values. Okay, so that means that my x values are going to stay the same. So my x values will stay -4, -2, 0, and 1. What am I doing to my y values? I'm multiplying each of them by 2. So this is -2, -8, 4, and 4. All I did is double each of them, right? All right. Same thing over here. Notice the 1/2 is on the F. So it's on the outside, right? That means, again, I am changing only my y values. So this is going to be x. This is going to be y equals 1/2 fx. So my x values from here are going to stay the same. -4, -2, 0, and 1. Okay. What am I doing to each of my y values? I'm finding half of them. So half of -1 is -1/2. Half of 4 is -2. Half of 2 is 1. Half of 2 again is also 1, right? And this is supposed to be a 1 there. I don't know why it looks like that, but it's supposed to be a 1. There we go. And there's my table. Okay. Okay. So now, let's look at the next part. So now we're talking about horizontal stretching and shrinking. Okay. So guys, now that we're talking about horizontal, these are going to change my x values, okay? So it says, if the point xy lies on the graph of y equals f of x, then look what we have here. X divided by c, comma, y lies on the graph of y equals f of cx. Notice where the c is. See it's on the inside? And it says, if c is bigger than 1, the graph of y equals f of cx is a horizontal shrinking of the graph. And when c is between 0 and 1, y equals f of cx is a horizontal stretching. Okay. So it says now, construct tables for y equals so on and so forth. All right. So y equals f of 2x. Okay. So notice where the 2 is. The 2 is on the inside. And the way I'm going to find my new x values, guys, is I'm going to take my x values and I'm going to divide them all by whatever the number c is. In this case, it's 2. Okay. So notice what we have here. I'm going to take these x values and I'm going to divide them all by 2. So -2 divided by 2, -1. -1 divided by 2, -1/2. 1 divided by 2, +1/2. 2 divided by 2 is going to be 1. Okay. So those are my new x values. My y values, guys, are not going to change because the 2 is on the inside of the parentheses, which is changing the x values, not the y. Okay. All right. So we'll do the same thing here. X and f of 1/2 x. Okay. So again, what am I going to do? I'm going to take the x values and I'm going to divide them by my number c. So I'm going to take each of the x values and I'm going to divide them by, look at the number that's there. I'm going to divide them by 1/2. Think about it this way. Remember when we used to do this like in elementary school, x divided by 1/2? You can think of that as x over 1. So that would be x over 1. Remember how we divide fractions? We change it to multiply and we do the reciprocal. And look what I'm coming up with, 2x, right? Excuse me. So now what I'm going to do is I'm going to take each of my x values that I had from up here and I'm going to double each of them, okay? So -2 times 2, -4. -1 times 2, -2. 1 times 2 is 2, and 2 times 2 is 4. My y values, once again, my friends, are going to stay exactly the same, okay? All right. So now we're going to talk about reflections, okay? Reflections across of the graphs across the x and the y axis. And it says if y equals f of -x, that's going to be a reflection of y equals f of x across the x-axis. And if we have y equals f of -x, that's going to be a reflection of our graph across the y-axis, okay? So first thing we're going to do, we're going to look at our graph here, okay? I'm going to make a table of values. Before we had tables, now we only have the graph, but we can make our own table for the original picture, right? So when x is negative 2, y is negative 1. When x is negative 1, y is positive 2. And when x is 3, y is positive 1, right? There's the graph. There's my table for those points right there, right? And all I did is just put my x and my y points. Okay, so now look what we're doing. We're going to make a table for y equals negative f of x. So think about it this way. What am I doing? I'm taking each of my y values and I'm multiplying them by what number? By negative 1. So my x values, guys, are going to stay exactly the same. So that'll stay a negative 2, that'll stay a negative 1, that will stay a 3. But these guys right here are now going to be multiplied by negative 1, meaning I'm just going to change their signs. So this here will be a positive 1, this will be a negative 2, this will be a positive 1, okay? Now, I'm going to show you something visually, okay, so that we get an idea of what is it I'm doing other than just kind of following some kind of basic rule, okay? So I'm going to graph this in red. So negative 2 and positive 1 would mean go to the left 2 and then go up 1. Negative 1 and negative 2 would mean go to the left 1 and then down 2. And then, let's see, oops, this should have been a negative 1, right? And then positive 3 and negative 1 would have been right here. And if I connect these dots here, what in essence what we've done is we've said, look, let's take this line right here, and if you flip the blue graph, let's see if I can get the color blue on here. There we go, yeah. If I flip this graph here, kind of downward, I can't even show you how to do it, but if I were to kind of do that, I would end up with a 1 in red, okay? And that's what we mean by reflection across the x-axis, right? All right, so let me clean up this mess, right? Okay, and now let's do the next part, because there is another one. All right, so now we're going to make a table for y equals f of negative x. So x, y equals f of negative x. Notice what we're doing. The x values, those signs are going to change. So I'm going to come back over here, and I'm going to change those x values to be a positive 2, a positive 1, a negative 3, but my y values, guys, will stay exactly the same. Okay. All right. So let's see if we can do this in pieces. Okay. So a lot of times when it says given the graph of y equals f of x, draw graphs for, and it gives me a couple here. So I'll tell you, first thing I'm going to do, I'm going to make a table, because I think making the table makes this easier to do, okay? So let's plot this, put these points, so negative 2 and positive 2, 0 and negative 2, 2 and negative 2, right? Okay, so now I'm going to make another table now. This is y equals f of x plus 2, okay? So notice, my x values are not changing because that's still the same. So my x values will stay negative 2, 0, and 2. But my y values, I'm going to add 2 to each of those numbers. So 2 plus 2 is 4. Negative 2 plus 2 is 0. And, I'm sorry, this was a positive 2 over here. Not a negative 2. And the negative was on top. All right. So that was a, oh wait, no, that was not negative on top. Sorry about that, guys. All right. And so 2 plus 2 is also 4, right? So now we're going to go over here. Negative 2, positive 4 is right there. And 0 and 0 is right here. And 2 and 4 is right here. And here's my graph. And again, if you do a little stare and compare, we just moved it up 2 spaces, right? Okay. All right, so let's do that again. Okay, so now this one a little more complicated because we have more pieces involved. So let's do it piece at a time. So look what we have there. We have a minus 2. Okay, so when we have x minus 2 like this, it means we're going to go to the right 2 spaces. Okay, so if I'm going to go to the right 2 spaces, guys, what I'm going to do now is with my x values, I'm going to add 2 to each of those numbers. So negative 2 plus 2 is 0. 2 plus 0 is 2. 2 plus 2 is 4. Okay. And there's a second part, because I have this, means I'm going to go down 1 space. Okay. So I'm going to go minus 1, minus 1, minus 1. So 2 minus 1 is 1. Negative 2 minus 1 is a negative 3. 2 minus 1 is 1. Okay. And so what I'm going to do now is let me, oops, I erased a little too much, but that's okay. We'll fix it here. Oops. Y equals f of x minus 2 minus 1. Okay, so now let's go ahead and plot those points. So at x is 0, y is 1. When x is 2, y is a negative 3. When x is 4, y is 1. And there's my graph. So we moved it to the right 2 and down 1 spot. Okay. All right. So now we have a part C. So let's do a part C. Okay. So I'm going to copy the original table that I had earlier, just because I can't see it right now. And so what were my numbers again? Here we go. Let me just write them here. Negative 2, 0, 2, and 2, negative 2, 2. 2, negative 2, and 2. Okay. So this was my original graph. Okay. Now we're going to make one for this part, right? Okay. So again, if you notice, where's the negative sign? It's on the outside. So since it's on the outside, guys, my x values are not going to change. Okay. My y values, all I'm going to do is change their signs. So that becomes a negative 2. That becomes a positive 2. This one also becomes a negative 2. Okay. So negative 2 and negative 2 is right here. 0 and 2 is up here, and 2 and negative 2 is down there, and there is my graph. Okay, there's my graph. So guys, it's going to take a little time to kind of figure this out, but you want to just take your time with it, right? You can always refer back to, let me scroll back up here, where we have some of this. Let's see. And I'm actually going to attach a kind of like a cheat sheet formula type thing that it kind of helps you realize this piece right here. I'm going to attach a formula sheet to your notes that'll show you, okay, like how do I know when I'm going to do this, or how do I know when I'm going to do that? Okay. All right. So we got another one similar. Okay. So let's see if we can't figure it out. First thing I'm going to do, let's make our table. X, Y. Okay. So negative 2 and 0, 0 and 2, 2 and 0. Okay, there's my original one. All right, so let's do part A. Look where the plus 1 is. It's on the inside. Okay? If it's on the inside, I'm going to change my x values. Okay? So I'm going to change my x values. If it's a plus 1, I'm actually moving to the left 1 space. Okay. If I'm moving to the left, that means I'm going to subtract 1 from each of those numbers. So minus 2 minus 1, minus 3. 0 minus 1, minus 1. 2 minus 1, 1. My y values will stay the same. Okay. So I'm going to go negative 3, 0, which is right here. negative 1 and 2, which is right there, 1 and 0, which is right here. Oops, can do a little bit better than that, right? There we go. And you can see all we did is we moved it to the left one space. From here to here, we moved to the left one space. Okay. Alrighty. Let's try the next one here. So notice where the negative is. It's on the outside, right? If it's on the outside, I'm changing my y values. Okay. So let me scroll up just a little bit so I can see my original table. Here we go. So my original table has these x values. Those will stay the same. Negative 2, 0, and 2. My y values, all I'm going to do, guys, change your signs. That's still 0. This is now a negative 2, and this is 0. So negative 2 and 0 is right here. 0 and negative 2 is over here. 2 and 0 is right there. Here we go. And you can see what we did is we flipped it, didn't we? We flipped it across the x-axis. Okay. All right. And we have a part C. And my x values are not going to change, so our x values were originally negative 2, 0, and 2. My y values, I'm going to take each of those y values, because this is on the outside, right? So again, since it's on the outside, I'm changing my y values, okay? I'm going to go to my original y values. Let me scroll back up. And I'm going to take these y values, I'm going to multiply each of them by 2. So I'm going to take each of these numbers here and double them. So 0, 2, 0 should be 0, 4, 0. So negative 2 and 0 is right here. 0 and 4 is 0. 2 and 0 is right there. And there's my graph. So that guy right there, guys, is 2.7, okay?